Bismillahirrahmanirrahim. Today we are going to discuss a very important comparison in our curriculum, which is between motor and dynamo. And let's start. If we start comparing between them by studying the rule through which we can understand the operation. As for motor, we study motor in terms of Fleming left hand rule, while we study dynamo through Fleming right hand rule. And don't forget that in the two indications, the motion is represented by the thumb. The pointer shows the direction of the field, and the middle with the rest of the fingers represents the current. Either it is an original current of a battery or an induced current. But we have to distinguish between the input and the output. In motor, the input is a current, while the output is motion. It is like a fan. When you input a current into your fan, it outputs its motion. On the other hand, the input in dynamo is motion, while the output is the induced current. And it is like a turbine. When water falls, it rotates its axle to transmit the motion to special magnets prepared for generating an induced current. And let's move on to the next point, which is the function. Of course, a motor converts electric into kinetic energy, while a dynamo converts kinetic into electric energy. And this is clear when we can study the straight wire or the coil rules, looking carefully to the input here. By sine theta, we input the current in the field, and so that the field interaction output the motion in terms of one force, and here in terms of two forces. We input the current, and the interaction of the fields output two forces that rotates the coil. Of course, it is the magnetic torque, as you will know. On the other hand, we input here motion, represented by velocity or by omega of rotation, and the interaction of fields output the opposite result to get electromotive force induced belv sine theta, or in a coil nab omega sine theta, or nabo sine theta. And let's move on to another point, practical point, scientific idea here in motor magnetic torque, while in dynamo electromagnetic induction variation flux lines. Start position, a motor has to start horizontally. It must start horizontally to get its rotation, and if the motor starts vertically, it can't rotate. On the other hand, it is an option. It is selective for the dynamo to start either vertically or horizontally. Vertically to operate on sine graph, vertically on sine graph, horizontally on cosine graph, and it is a should, not a must. Maximum value, both has the maximum value as a horizontal position in which the angle equal 90 with the field. And here the angle included between the normal of the coil and the field. The normal of the coil here is represented by the magnetic dipole moment, while there is represented by the vector of velocity. Start position here, output electromotive force equals 0, and as I mentioned, we select that to operate the dynamo through the sine function, and it is an optional position. We may give the dynamo its rotation through the horizontal position, while as I mentioned, the motor must start rotation from the horizontal position. Let's move on to another point of comparison. The rule of the brushes is the motor input the current from the source to the coil, while in the dynamo output the current from the coil as it acts as a source to the external circuit. Commutator in general output in one direction, here output motion in one direction, while there output current in one from the same brush in one direction. So many coils to keep the maximum torque during rotation, while here to output unidirectional current of nearly maximum value. And that's all for now. Thanks for watching.